Hello everyone, my name is Tao Yan. Today we are going to share our research about how to pwn IIS and the SQL Server with the vulnerabilities in Microsoft Jet database engine. Our topic is Give me a SQL injection, I shall pwn IIS and the SQL Server. The name of this topic is from the famous Greek scientist Archimedes. He has a famous assertion to demonstrate the principle of the lever. Give me the place to stand, I shall move the earth. I would say pwning IIS and the SQL Server is as difficult as moving the earth. We both need a precondition. Here's our agenda. We'll firstly introduce why we do this research, and then we will introduce what new discoveries we found in IIS and the SQL Server. After that, we will show examples to prove our discoveries. At last, we will summarize the whole topic. Who are we? We are security researchers from Palo Alto Networks. We have spoken at many different security conferences, Black Hat, Kansas West, Blue Hat, Recon, etc. We are also regular top vulnerability contributors for Microsoft, Adobe, Apple, and so on. Let's start from the motivation and background. Our research started from these three questions: new attack surface in IIS and the SQL Server. Can we do more with the SQL injection? Who can use Microsoft Jet database engine? We will show how we connect these three same unrelated topics together. Attack surface in IIS and the SQL Server are very limited, especially for memory corruption vulnerabilities. You can see in this figure, the last memory corruption vulnerability in IIS appeared in 2009, over 10 years ago. Attacking IIS and the SQL Server directly is much too difficult. So what if we have a SQL injection in advance? SQL injection can be used to execute an intended SQL queries in target database. Usually, it is used to view data in the database, especially in Access. For more powerful database like SQL Server, only if you have high database privileges in the SQL injection, otherwise you cannot execute shell commands. Even more, you cannot execute a native code in the application or database process. But if there's a vulnerability in database engine, we could get that capability. It's easy to bring the Jet database to the stage. Firstly, it's very old and not well maintained, but still massively used. Secondly, it is native supported on all Windows versions. MS Jet 4.0 is installed by default on all Windows versions. So the next question is, who are using Jet? Since there's a vulnerability in Jet database engine, it will also be affected. The first option is Office. Office supply an interface to let users to link an external database source, but it is not an ideal target since, firstly, it cannot execute SQL queries on the new linked database file. Second, the protective view mode of Office will mitigate the external link source. The other option is WScript, but it is not also an ideal target since it can only crash WScript locally and did not break the security boundary. What about Access and SQL Server? Since we have known Jet is the default database subsystem used by Microsoft Access, so it is possible to use vulnerabilities in Jet database engine to attack IIS and the SQL Server by executing any SQL queries on remote controllable database. The answer is yes. Now we come to the main dish. we will introduce the new remote attack surface on IIS and the SQL Server. This chapter will detail what the new discovery is, how SQL injection connect SQL IIS and the SQL Server with Jet database engine. Let's see the cross-database SQL query in Access and SQL Server first. In Access database, it's very straightforward. You just need to put external database before the table name. In SQL Server, there are three ways to do that: open data source, open role set, add link server. In each way, you can set external database to the data source parameter, database parameter, date src parameter. Access use Jet provider by default, so it will use MS-Jet 4.0 to do the cross-database SQL query. Is it possible to use Jet to do cross-database query in SQL Server? The answer is yes. You only need to set the provider with these strings, Jet 4.0 or ACE 12.0 or 6.0, to let SQL Server with the related Jet database engine to do the cross-database SQL query. It is very interesting, right? SQL Server can use Jet database engine to do cross-database SQL queries. Assigning the provider with and using MS-Jet to do cross-database query in Access and SQL Server is not enough. If external database can be on the remote server, that will be a very powerful capability, since the attackers can control the database file remotely. In the document, we see both local file system and shared network folders are supported. Let's check the code. In MS-Jet 4.0, there's a function named error try open database is responsible to parse external database. If we set a UNC path, and it will check if it is a foreign database and go to different branches. And you can see MS-Jet 4.0 module, MSRD, and MS-Excel will be called. But finally, all different code branches will call create file to open the external database file. Similarly, in MS-Jet 12.0, it will also call create file to open external database. Usually, Windows use SMB to parse UNC path in most applications. But there's a hidden feature for create file with UNC path in IIS and SQL Server. It both use SMB and surprisingly also use WebDB. You can see it firstly will connect 445 and 139 port with SMB protocol, and then if failed, and it will connect 80 port with WebDB protocol. Very interesting, right? If we set up an SMB server, it works on Windows 7, fails on Windows 10. We guess there might be some mitigations to mitigate SMB, NTLM, harsh leak issues. If we set up a WebDB server, IIS and the SQL Server successfully get the external database file from the remote WebDB server. It works on all Windows versions. WebDB and SMB are not all story. You can see there's a more feature in MS Excel 4.0. And you can see there's a net protocol type function. It will check if the input is a FTP protocol. If yes, it will call net download to local function to download the remote database file from the FTP server. This function will call APIs in WinINet to communicate with the remote FTP server. You can see IIS and the SQL server connect 21 port with FTP protocol. After we know Access and the SQL Server support cross-database query and external database can be on the remote WebDB server, let's see what will happen about cross-database query in SQL injection. This is a typical SQL injection case in Access. You can see we use ID to inject or customize SQL query. After the injection, both original SQL query and the injected SQL query will be executed by ASP code. Let's see how IIS and ASP deal with the injected SQL query in IIS process. The functions in ASP will call module VBScript, MSADO, ODBC32, and finally it will call try open database to open external database. As we just introduced, this function will call create file finally. This is a typical SQL injection case in SQL Server. Similarly, we also use ID to inject or customize SQL query, and both original SQL query and injected SQL query will be executed by ASP code. In this case, we use open data source as an example, and it set the provider with ACE 12.0 to let the SQL Server use MSJet 12.0 to do cross-database SQL query on the remote database file on the WebDB server. Different with the Access case, it is a SQL Server process that deal with the injected SQL query. If we use Jet 4.0 as the provider, you can see SQL Server will use Jet open database function in MSJet 4.0 module to open external database. Finally, it will call query file. If we use Jet 12.0 as the provider, you can see SQL Server will use functions in ACE core to open external database. Finally, it will also call create file as we showed before. Let's summarize this new attack surface. It grants attackers the ability to execute any SQL queries on any attacker controllable database in IIS and SQL Server based on a SQL injection. It means vulnerabilities in Jet database engine can be used to attack IIS and SQL Server. So we do fuzzing based on the mutations on SQL queries and Jet database files. With this strategy, we have found around 100 vulnerabilities. It's a huge gold mine. Hope you can find your own vulnerabilities to attack IIS and the SQL Server with this method. Now we come to introduce 3 attack scenarios under this new attack surface in the real world. In each scenario, we will detail the new attack surface impact and the requirements, as well as show the examples of vulnerability details, including the demos. First scenario, IIS and Access. In this scenario, all set up by default, except you have a SQL injection. And all Jet 4.0 components are vulnerable. and you only need one single web request to cause IIS, DOS, Infolic, or RCE with the same privilege of the IIS process. Although you can only use select query in this scenario, but it is good enough to find the vulnerabilities. Let's see an example. You can see only one select query is injected with the SQL injection, and it will execute the SQL query on the remote external database on the WebDB server, and it successfully caused the IIS crash. Let's analyze this vulnerability briefly. You can see EAX is from the ESI plus 34 offset. ESI is a table mover object, and the record address set the value at the offset 34 of table mover object. And if this function return 1, the code will go to the branch of accessing the invalid memory and cause crash. Please keep it in mind, we'll introduce it later. Comparing the memory dump of table mover object before and after, you can see record address function will set an invalid value at the offset 34. It's you can see here it is an end address of a heap, right? So record address is responsible to parse record information from the database. You can see it is the record information from the database, and this field will be parsed to calculate the length, but it did not check the equal condition, right? Since the length is equal A00 after the calculation, it did not check. So the code will go to here to set the invalid value of the 34 offset. This is not the worst case. You can see here 4800 will make this function return 1, and the code will go to the invalid memory access code branch and cause crash. If the word value is say800, and it will make the function return 3, and the code will call set error, and then no crash happens. So you can see only 1 byte change can cause IIS crash. If C8 in original file, there's no crash, and there's if it is 48 byte, it will cause crash. This is the first time you see the power of the database file mutations. Regarding to the select query, nothing special. So let's see the demo. Firstly, it's a web server address, and it's IIS process. We use WinDebug to attach the IIS process, and then execute this web request. And then we can see this is an external database file on the remote WebDB server, and we execute the query in our browser, and okay, IIS crashed. Scenario 2, IIS and the SQL server. In this scenario, There are two cases, 32-bit and 64-bit. In 32-bit SQL Server, all JET components are vulnerable. In 64-bit SQL Server, only ACE core means the JET 12.0 is vulnerable. In SQL Server, all SQL queries are supported. No restriction about the SQL query, and if the ad hoc is turned on by default, if the ad hoc turn on and you don't need any database privilege in the SQL injection, public is good enough. Also, you only need one single web request to cause SQL Server DOS, Infilic, or RCE with the same privilege of the SQL Server process. Here is an example. You can see we injected one query update, and we use open data source to let SQL Server use MSJet 12.0 to execute this SQL query on the remote database file on the WebDB server, and successfully caused the SQL Server process crash. Some information of this vulnerability. You can see EDI is an invalid value, and it is from this object. Comparing before after, we see the before something happened, this value with yellow color is valid, but something happens, this value is overflowed. And we can see also 00 become 1B, 1B. There must something wrong happens. Let's see further. This small piece of code is responsible to update some values in the memory in a loop. In each loop, it will add the memory value with a fixed value 1B. In each, the loop count is 3E. So let's investigate what the correct loop count. You can see here the values with yellow color. After our investigation, it is the column value from the database file, and it should be updated. But the values with red color, there are some memory pointers over there. It should not be updated. So the correct loop count should be the hex 28, but the actually loop count is 3E. So there's out of boundary right happen. Where the loop count 3E from? Is it controllable? Is there any check? Let's see. No check at all. You can see the loop count 3E is defined in the database file, and it is read directly to this memory structure, and the code read the loop count 3E directly from this memory structure and do the loop. So if we set 3E with a big value, then more content in the memory will be out of boundary overflowed. So this is the second time you see the power of mutations on the database file. This case is more complicated comparing the first one. You need to do the mutations in the two positions. In the first position, you need to set the valid column information here. In the second position, you need to set a a value larger than 28 to make the overflow. Regarding to the update, nothing special about it. Just update the SQL query. Let's see the demo. Web server address, SQL server process, and we use WinDbg to attach the SQL server process and execute the SQL queries with the SQL injection. Okay, we successfully caused the SQL Server process crash. Scenario 3, IIS and a web shell. Usually, if you have a web shell, you can execute command with a command module in the web shell. But sometimes there are mitigations and restrictions to prevent web shell command module execution. In this case, native code execution capability is important since it can bypass any restriction or mitigation in the memory. So you can use JIT vulnerabilities in the web shell to get the native code execution capability. In the web shell case, all JIT components are vulnerable, and all SQL queries are supported. No restriction for the SQL query, and you can use a database module in the web shell to trigger. Here is an example. You can see we set provider and we set data source and execute those 4 SQL queries in the web shell one time, and then successfully caused the IIS crash. Pay attention the crash point. Here is a call EX. Very interesting, right? It's very close to exploitation, and we can control the EX to 410, and if we put the heap spree and it will execute arbitrary code in the IIS process. Some briefly analysis for the vulnerability, and you can see EX is from ECX. ECX is the page description object, and the zero offset of this object is the vtable. And after something happened, you can see the vtable is overflowed by a string. This string is exactly same with the string in the update SQL query. Very interesting, right? Let's see what happened. There's a memory copy over here, and it used the size of source buffer as the copy size. You see? No check for this size. No validation, no verification, just copy directly. It's a very classical vulnerability pattern. Let's see more about the destination address and buffer. The destination buffer size is 1000, but the destination address is from the offset BCC, so there are only 434 bytes left, but the copy size is 44E from the source buffer. So there is overflow happened. just right after the destination buffer. This is a page description object, and we can control any value and just exactly override the page description object. So this is the first time you see the power of mutations on SQL queries. You can see only one update can cause an overflow, but those three SQL queries make a successful heap layout to make the page description object just right after the destination buffer. If you want also do a successful heap grooming, I suggest you execute multiple SQL queries in one database connection, and also try cache is necessary in the web shell. Let's see the demo. Also the target address and the IIS process. Same, use WinDbg to attach the IIS process and execute those 4 SQL queries. Yeah, the external database on the WebDB server and execute. Okay, IIS crash at the call EX. Very interesting. A short summary for vulnerabilities in 3 attack scenarios. They are very old, over 20 years old. It works from Windows XP to Windows 10. They are not hard to exploit since there are no or weak mitigations. For example, no CFG at all in MSJet 4.0 components. The damage is severe since a successful exploitation can execute any code in IIS and the SQL Server process. Since IIS and the SQL Server has the SE impersonate privilege capability enabled by default, so it's easy to use token kidnapping technique to escalate the privilege to system. So it is possible from a secure injection to remote system. Let's summarize the whole topic. WebDB, is it a feature or vulnerability? It's always controversial. Actually, WebDB opens a new world for attackers to remotely attack IIS and the SQL Server. We reported a lot of JET vulnerabilities to attack IIS and the SQL Server to Microsoft. Microsoft will patch the vulnerability one by one or patch this WebDB feature, we'll see. Second, backwards compatibility. It is very friendly to users, but it always brings security issues together. Third, defense and mitigation, especially for systems which are no longer supported by Microsoft. I would say pay more attention to WebDB, disable outbound WebDB traffic on your server if you don't need it. Next time, when you see a secure injection, think more about it. There's one more thing. We want to discuss the security boundary. When you report a vulnerability to Microsoft, they will ask you how and what security boundary it breaks. We reported a lot of JET database vulnerabilities to Microsoft in the past several months. Sometimes Microsoft reply not break the security boundary, either close the case or keep pending the cases. What's the essence of JET vulnerability? Think about it. From our perspective, it makes SQL query execution equal native code execution. It is a very powerful capability since there are a lot of systems components using JIT and allow SQL query execution. In today's presentation, we combined SQL injection with WebDB, bring SQL query execution capability to IIS and SQL Server. It means we can get the native code execution capability in IIS and SQL Server with JIT vulnerabilities. This is a remote attack surface. The security boundary is from SQL injection to remote system. How about the local attack surface? Think about it. We leave a hint here. It may become a part of our next Black Hat talk. Before the end, we want to thank our colleague Zhibin. That's the end of our presentation. Thanks for listening.